Yo, 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 this is Mr. Lane coming back at you with another exciting video from OHS High School. This one will be section 9.2, over circles and regular polygons. So make sure you read the objective and the why, and answer number 5 in your notes. A few things about circles, and I think we've got pages for each one of these, but good drawing always does help get us started. So distance around a circle is the circumference. Right through the segment right through the center of a circle that goes from side to side is the diameter. Any segment that goes not through the center but goes from side to side would be called a chord. The radius, of course, goes from the center to any point on the circle, and a secant is a line that goes through a circle, cutting through it in 2 points. A line that goes through cutting at 1 point would be called a tangent line. So here's the definition of a center of a circle. Here's the definition of a diameter, definition of a radius, definition of a chord, defo of a secant. There's the circumference and the circumference formula. You definitely want to make sure that you put that formula in your notes somewhere. There's the area formula for a circle. Make sure you have that also. And it looks like we're ready for some examples. We're supposed to find each measurement, the area of the circle K in terms of pi. Some people get freaked out when it comes to terms of pi, but it's really easier than if it wasn't. So here's our area formula. Area is equal to pi r squared. Pi's are round. Alright, so it looks like our whole diameter is the 6 inches, so our radius is going to be half of that, which is 3 inches. So I square that, and it looks like our area is going to be equal to 3 squared would be 9 pi, and then you always want to make sure you label it, and any type of area is going to be inches squared. Alright, the radius of circle J was the circumference of that, pi meters. So circumference is equal to 2 pi r. And we're going to fill in the 65x plus 14. And that's pi is equal to 2 pi r. Well, we're solving this for r, so I need to get rid of the 2 pi. So I'm just going to divide that real quick by 2 pi. Bada boom, bada bang. The pi's are going to cancel out right there. So I need to divide 65 by 2, which would be 32.5. That's x. And then 14 divided by 2 would be a 7. And I found what my radius would be equal to. So 32.5 x plus 7 meters is equal to the radius. Alright, let's see the circumference of the circle M if the area is, alright, so the area is 25x squared pi, and the circumference we're supposed to figure out. So I'm going to start by just filling in pi r squared is equal to 25x squared pi. So the first thing I need to do is divide by pi to get rid of it, and notice that's going to cancel out on the other side. So bam, they're gone. Then I need to take the square root to get rid of the squared. So the square root of 25 would be 5. Square root of x squared would just be x is equal to my radius. So now I'm supposed to find the circumference. So the circumference is equal to 2 pi r. And I'm going to fill in my radius of 5x times pi times 2. So 2 times 5 is 10, so I'm going to have 10x pi, and it looks like it's in feet. Circumference is just in singular units. So, alright, regular geometry students, bam, right there, 2, 4, 10, 12. And hopefully iPad initiative students, you should be on your Lumen Touch website. Alright, a pizza making kit contains 3 circular baking stones with diameters 24, 36, and 48. Find the area of each stone, round it to the nearest tenth. So a little calculator work here. Shouldn't be that hard. Remember pi r squared. So we got to divide all of these by 2 for the formula. So that one would be 12 that would be plugging in. This one would be 18 that we're plugging in. This one would be 24. So the area of the first stone would be pi times 12 squared. So 144 times our pi, and I would use the pi key on the calculator if you have it. Otherwise 3.14 should be close enough. So if we get that out here, handy dandy calculator, we got 144 times 3.14, and bam. So the area of the first stone is 452 and 0.2 centimeters squared. Alright, so the next one we would have pi times 18 squared. So I'm going to take 18 and square it real quick. Then multiply it times 3.14. And it looks like the area of the second stone, 1017.4 centimeters squared. And we'd have the 24 left to plug in. I'm sure you can do it on your own. Be a good thing to put in your notes. Give you a few more notes if you wanted. Alright, let's move on. There's the regular geometry students. iPad, yours should be on Lumen Touch. Alright, on this we have the center of a polygon now, is P here. A radius of a polygon is going to go from the center to any vertice on the polygon itself. Now, this one is going to be real important. This is called the apothem, and the apothem is the perpendicular distance to one of the sides of the polygon right to the center of the polygon. So we're going to be using that segment, so you need to learn what that is real quick. Central angle, any angle that is formed by 2 radius from the center of the polygon. Alright, the area of a regular polygon with an apothem A and a perimeter P is equal to 1/2 the apothem times the perimeter. Okay, make sure you got that formula down. It just describes what a radius again is, what apothem is, and how we find a central angle. Alright, find the area of each regular polygon to the nearest tenth. Regular heptagon with side lengths of 2 foot. So a heptagon is going to have 7 sides. Each of those sides are 2 foot. So that's going to be That's going to be 14 foot for the perimeter. Alright. Now for the apothem, we need to figure out what one of these central angles are. So we're going to have 360 divided by the number of sides 7, and that's going to come out to be not good. Alright, the last problem there, we needed to know some trig functions to solve. So we're going to switch this just to a hexagon real quick, and the central angle on hexagon would be 360 divided by 6, which is 60 degrees. Okay. Okay. So now that we know what a central angle is, we're going to drop the apothem from it. That's going to cut this 60 degrees into a 30 degrees, a 90 here, and a 60 degrees here. So we got a 30, 60, 90 degree right here. And then we've got 1, because halfway across the apothem's always going to cut the side in half. So if the side was 2 foot, now we're going to have 1 foot. Okay. Now I need to figure out what this length of the apothem is. So across from the 30 is 1. So that means from my 30, 60, 90, if I wanted the longer leg, I multiply that by radical 3. So 1 times radical 3 would just be radical 3. So now I know the length of the apothem is just regular 3. So the area is equal to 1/2 the apothem, which is radical 3, times the perimeter, which is going to be 6 times 2, or 12. So half of 12 would be 6, so 6 radical 3 feet squared would be your area of that hexagon. Alright, I think we're about wrapped up for today. So this will be Mr. Lane signing off from OHS High School. Have a good day.